Simultaneous linear algebraic equation, Gauss elimination method. Gauss elimination method, it is also called as a direct method. This is the direct method based on the elimination of the unknowns by combining equations such that the n equations in n unknowns are reduced to an equivalent upper triangular system which could be solved by back substitution. Now consider the linear equation a11 into x1 plus a12 into x2 plus a13 into x3 is equal to b1, a21 into x1 plus a22 into x2 plus a23 into x3 is equal to b2, a31 into x1 plus a32 into x2 plus a33 into x3 is equal to b3. Now this system, it is equivalent to ax is equal to b. Now what is A? It is called as a coefficient matrix. So coefficient of x1, x2 and x3 we have to write here. So a11, a12, a13, these are the coefficient for the equation 1. a21, a22, a23, these are the coefficient for the equation 2. And a31, a32 and a33, these are the coefficient for the equation 3. Now x is equal to, here are three variables x1, x2 and x3. So you can write here x1, x2 and x3. These are the unknowns. You have to find the values of x1, x2 and x3. B is equal to, these are the constant values b1, b2 and b3. So b is equal to b1, b2 and b3. Now we will see one example for this method. Solve the system by Gauss elimination method. 2x plus 3y minus z is equal to 5. 4x plus 4y minus 3z is equal to 3. And 2x minus 3y plus 2z is equal to 2. Now the system, it is equivalent to x is equal to b. Now we have to write A matrix, X matrix and B matrix. So first you can write the A matrix. So first you can see the first column, it is a coefficient of x, it is a 2, 4 and 2, 2, 4, 2. Then coefficient of y, 3, 4 minus 3, 3, 4 minus 3. Then it is minus 1, minus 3 and 2, minus 1, minus 3 and 2. Then X matrix, it is three variables are there, x, y and z is equal to, these are the constant b1, b2 and b3. So it is 5, 3 and 2. Now go in the Gauss elimination method. Now this is the first element of the second row, you have to make 0. Then first element of the third row, you have to make a 0 here. And second element of the row 3, we have to make here 0. Now you see how we can make the 0 here. So here it is a 4 and here it is a 2. So you can take the help of R3 as well as you can take the help of R1. Now for the Gauss elimination method, we are using a row transformation only. So this element you have to make 0. So R2 minus, here it is a 2. So multiplication factor, it is a 2. So minus 2 into R3. Now change in only R2. There is no change in R1 as well as R3. So you can write here R1 as well as R3. This is R1 5 and this is last R3, it is a 2. So you can write here. So there is no change in R1 and R3. Change in only R2. So for this row, multiplication factor, it is a 2. So 4 minus 2 into 2, it is a 4, it is a 0. Then here it is 4. 4 minus 2 into minus 3, it is a 10. Then minus 3, minus sign, 2 into this 2, it is a minus 7. Then 3 minus 2 into this 2, answer it is a minus 1. Now this element, it is a 0. Now we have to make first element of row 3 0. Now we'll see. Now this element, it is a 0. Now we have to make this element 0. So for this you can take the help of R1. So R3 minus R1, here it is a 2, again here it is a 2. So change in only R3 and there is no change in R1 and R2. So you can write R1 and R2 as it is. There is no change here. There is no change here. So 2, this is 2 minus 2, it is a 0. Minus 3, again this minus 3, it is minus 6. 2 minus into the bracket minus 1, it is a 3. Then 2 minus 5, it is minus 3. Now this element, it is 0. Now second element of row R3 you have to make a 0. Now for this you can take the help of row R2. You cannot use row 1 because here it is a 2. If you want to make any changes here, then this 2 comes here, so it is not possible to keep this 0 again. So for this you can take the help of R2 only. So here it is a 10 and here it is a 6. So multiplication factor for this R3 it is a 10 and for this R2 it is a 6. So 10 R3, this is the minus sign, so you can take here plus 6 into R2. So change in only R3, there is no change in R1 and R2. So you can write here as it is 2, 3 minus 1, 0, 10 minus 7, 5 and minus 7, 1. So there is no change. So change in only R3. So 0 minus 0 it is a 0. So you can multiplication factor here it is a 10. So 10 into 6 it is a 60 minus 60 plus 6 into 10 it is a 60 plus 60, so it is a 0. For this multiplication factor it is a 10. So 10 into 3 it is a 30 plus sign 6 into 7 it is minus 42, so it is minus 12. So 10 into minus 3 it is minus 30 and here it is minus 6. So addition will get here minus 36. Now this element it is a 0. So this is called as a upper triangular matrix. So you can see here, now this is 0, this one it is 0 and this one it is 0. Now from this matrix we have to write equations. So row into column, this is a row into this column. So 2 into x, so 2x plus sign 3 into y, 3y minus 1 into z minus z is equal to 5. So this row into column. Second equation 0x plus 10y minus 7z is equal to minus 1. Then 0x plus 0y minus 12z is equal to minus 36. Now these are the equation number 1, 2 and 3. So from equation number 3, here it is minus 12, z is equal to minus 36. So 36 divided by 12 you can take here, so z is equal to 3. Now for this Gauss elimination method we are using back substitution. So z is equal to 3, you can put this value into the equation number 2. So 10y minus 7z is equal to minus 1, value for z it is a 3. So 10y is equal to 20, y is equal to 2. Now this value of z and y you can put into the equation number 1. So 2x plus 3y minus z is equal to 5. 2x plus 3 into 2 minus 3 is equal to 5. So x is equal to 1. Now values of x is equal to 1, y is equal to 2 and z is equal to 3. Thank you for watching the video.